Hello and welcome back to another episode. In today's episode, we're going to be covering exponents. So exponents are something that I feel like a lot of people struggle with, and especially in calculus because we start looking at exponents in a slightly different way, and I'll be explaining that a little bit. Um, of course you do learn this in algebra, but I feel like by the time you get to calculus, a lot of people forget this method of displaying exponents. So let's first go ahead and highlight what exactly are exponents. So in the same way that having multiplication is repeated addition, having exponents is repeated multiplication. So if we see x to the third, that means we have x times itself 3 times. And there is some visuals that can be done with this. Basically, every time we take an exponent, we add a dimension. But once you get past the third exponent, that becomes rather obsolete. However, that is what exponents are at their nature. The hard part isn't understanding exponents, but understanding all the little nuances that come with exponents. So let's first go ahead and look at some different ways of representing exponents. If we have x to the negative fifth, this is the same as 1 over x to the fifth. So this negative exponent flips our variable down to the denominator. For some reason, a lot of people get confused about this, and rightfully so. It can be kind of confusing, especially the first time you see it, but anytime you see a negative, that's all that is happening. We're just flipping it down to the bottom. Then, if you see a fraction represents a radical. So, if we have, for example, x to the 1 over fifth, or let's do third, this is the same as 3 root x. And this is true for all fractions. So if we have x to the 1/5, this is 5 root x. And so you might be asking, well, what about when we have x to the 2 over 3, for example? This is 3 root x squared. And we can write it like this, or we can write it like this. These are the same thing. All three of these are the exact same meaning. So now that we have some of that basic formatting down and we feel, I hope, somewhat comfortable with it, let's go ahead and look at some of the rules, and we'll come back to these eventually. So if we take our exponent, and let's use a here, and we multiply it by something with the same base, then these exponents will add. So this is x to the a plus b. And now let's go ahead and give you an example. So if we have 2 to the third times 2 to the second, this is 2 to the fifth. So this is fully allowed because, again, if you think back to what the exponent is, it's just 2 times 2 times 2, and then we're multiplying that by 2 times 2. Or, in other words, we're multiplying 2 to itself 5 times. So that's why you're allowed to do this. Some people get confused, especially if you're looking at like x to the a times x to the b. That can be kind of confusing. But if we just ground it in an example, like 2 to the third times 2 to the second is equal to 2 to the fifth, then I hope that the intuition can kind of come through and you can understand what it is that we're actually doing. Now, if we have an exponent, so let's do our example here again. Yeah, we'll just erase this. and then we'll move our b. So if we have our exponent like this, and we're raising it to another exponent, this is the same as saying x to the a times b. So now, if we have x, and again, let's do 2. 2 to the second to the third, well, this is the same as taking 2 to the second and multiplying itself 3 times. So, in other words, we're taking this and multiplying it like an exponent. And if we look at our base from the last example where we have x times x to the a times x to the b is equal to x to the a plus b, well, we have the same thing here, but now this is 2 to the 2 times 3, right? We have 3 of these. And let's go ahead and put a little 3. So using the first two exponent laws, we can kind of start justifying why these work the way they do. And I feel like a lot of the times in math, if you just take a step back and ask, okay, why does this work this way? Can I use the other things I've learned to express this? It should help you. So those are the first two. Those are really important. You'll see those a lot. Let's go ahead and look at another law for exponents. So this is x to the 0 will always be equal to 1, except when x is 0. So 0 to the 0 is not going to be equal to 1. But for any other 5 to the 0, 7 to the 0, and again also infinity, it will not be 1. These are undeterminate or indeterminate forms. But for every other example, x to the 0 is 1. And this is also important. You'll see this quite a bit. There's some proofs if you want to go look at them, but I'm not going to provide that here. And then, again, like we said earlier, x to the negative 1 is simply 1 over x. Now let's move to the next one. If we have a times b to the power of n, this is a to the n times b to the n. And if we think about this again from the point of view of throwing in an actual example, let's say 5 times 7 squared, or actually let's do cubed. Well, we can see this is 5 times 7 times 5 times 7 times 5 times 7. And then because we're allowed to rearrange when we're multiplying, we can say, well, this is 5 times 5 times 5, and then 7 times 7 times 7. Or 5 cubed times 7 cubed. So that's kind of why that works. Again, just breaking it down and looking at these patterns hopefully make it a lot easier. So let's go ahead and look at a similar one to that now, which is a over b to the n will simply be a to the n over b to the n. And again, for the exact same reason, because if we have 3 over 4 squared, this is 3 over 4 times 3 over 4, or 3 times 3 over 4 times 4, or 3 squared over 4 squared. So just a different rewriting of the previous law. And then, like I said in the beginning, if we take fractions of exponents, so x to the 1/2, this is square root of x. And same thing with x to the 1 over 9. This is 9 root x. And so generally we can write this as x to the m over n will be equal to the n root of x to the m. And again, this can be rewritten as, let's do the root symbol. We can also rewrite it like this. These are equivalent, same meaning. Sometimes, especially in calculus, you might see instead of a fraction, we have a decimal up here. But same thing, it's just x to the 1/2. Let's go ahead and look at some square root identities and laws now. And then, yeah, I think that's about it after that. So, for square roots, we can separate them if they're multiplying. So for example, or for radicals, sorry, the root of a times b, we can do that as the square root of a times the square root of b. This is fully allowed. However, if we have a plus b, this will not be equal to the square root of a plus the square root of b. This is not allowed. You can't split it like that. However, if you had watched the previous video and you've learned a little bit about factoring, we can factor. So for example, let me erase these real quick. If we have the square root of 4x plus 8, let's make these both squared. So if we have the square root of 4x squared plus 8x squared, what we can do is we can factor out common values. So this is 1 plus 2 now. And then because this is multiplying, we can separate them like such. And so we know that the square root of 4 is 2, and then the square root of x squared is x. So this is one of the techniques you can use for simplifying your radicals. That is just about everything I wanted to cover in this video. A lot of exponent and square root laws, or radical laws, or root laws. And just to give you a good basis, especially once we start getting into more calculus heavy things, it's a good idea to be able to look at exponents and be able to use them either as fractions or decimals, and being able to convert between the two. Yeah, thank you guys so much for watching. If you enjoyed the video, make sure to leave a like and follow along for the series, and stay tuned for the next video where we're going to be tackling inequalities. Thank you so much. Have a good day.